All right, hello again, pre-calculus people. So starting a new unit today on exponential and logarithmic functions. And all we're going to talk about today is graphing exponential function. Now, this is something that you did back in Algebra 2, at least with relation to like all the parent functions that you went over. We'll get into the definition of logarithms and exponentials and their relationship. We'll do that in a couple of days, but for now we're just going to be graphing and looking at the transformations and kind of refreshing our memory on that. So let's talk about the parent function of the exponential. You're going to see it as something to the x power, right? That b, what we call the base, can be any number. It can't be negative, but it can be any positive number. It can be a fraction, whatever. The common ones you're going to see are either 2 to the x, 3 to the x, something like that. And the real common one is this e to the x. If you don't remember what e is, again, we'll talk about that a little bit later on. But remember, e is just a number that's very common in financial applications, science applications, and stuff like that. But if you recall, the domain of the function was all real numbers. And the range of the function was from 0 to infinity. And if we make a table of values and again, if I'm just going to do 2 to the x just for kind of easy operation and make the numbers a little bit cleaner. If we go like back to -3, the y value, so 2 to the -3 power is 0.125 or 1/8. And then at -2, 0.25, and I'm just going to fill these in. I'm not going to narrate while I do it. And if I were to plot these things, it's kind of hard to plot like the 1/8 and the 1/4 and 1/2 real accurately, but I'm going to try. So here is my y-intercept at 1. There's a half, there's a fourth, there's an eighth. Obviously going to get closer and closer on this end. And then when x is 1, it's 2, 3, 1, 2, 3, 7, 8. And I'm not going to have room for the 16, and that's okay. So if this kind of rings a bell, so the graph is going to be asymptotic, never hits the x-axis, comes up, and then once it gets across the y-axis, it's going to go up pretty doggone steep. Okay, so that's kind of what the graph looks like. That's what the parent function looks like. And there's one point in particular that I really want to point out to you. It's what I call a critical point, and it's the y-intercept. So when we do the transformations, that's what we're going to move, really. When we graph these things, I'm looking for really 3 things: is the critical point shifted and moved in the correct way? Is that in the right spot and labeled correctly? Is the asymptote in the right spot? And notice in my parent function case, my asymptote is just the x-axis, which is y equals 0. That's the second thing. And then the third thing is just the general direction of the graph going in the right direction. We'll talk about that in a couple minutes when we start talking about reflections and stuff like that. Okay, so that's what we have for the parent function. Again, that should ring a bell, but you definitely want to know the domain and the range. And I'm going to generalize what happens to the range and the asymptotes and all that good stuff like that in just a second too. Okay. So let's do a quick review also of transformations. And again, this is right out of your Algebra 2 days. So we have the A, B, H, and K values. Now the good news on A, when you're in Algebra 2, you talked about A's like a vertical stretch, vertical compression, and stuff like that. For exponentials, does a 2 or like a vertical compression or vertical stretch, does it change the graph? Yes. We're just not going to be too concerned about that this year. The main thing we are going to be concerned about, though, with a value, with exponentials and logs for that matter, are if there's a reflection going on. So the a value, the only thing we're going to worry about right now for this chapter is if a is less than 0, if a is negative, then it's a reflection across the x-axis, which In normal terms, this means it's upside down. Same thing with the B value. Remember, that's a horizontal stretch, horizontal compression, stuff like that. We're not going to worry about that either. Honestly, the whole A value and B value, we'll get back into those and really what they do when we get into trig. But for right now, really all we're going to be worried about in this unit is going to be reflection. So same thing with A. If B is negative, it's a reflection across the y-axis, which just means it's going backwards. That's also the decay function. So if you've heard of like radioactive decay and stuff like that, that's where the B value is negative. That's where you have a negative exponent. Okay, and then the H and K values, those are normal. Those are just your shifting left and right. And then the K is shifting up and down. Okay, so let's kind of jump into the examples here and see what this is going to look like. So I'm going to do example A, and then on the back of the page, I've got a graph where we're going to graph all these things too, and then I'll come back and do B and kind of do the same thing, and then there's two more on the back. So take a look at example A. So I got e to the x plus 3 minus 1. And again, I'm going to use e on all of these because all we care about, whether, it doesn't matter. Let me go back up here just 1 second. It doesn't matter what the base is here. The y-intercept is always going to be 0, 1. And the asymptote is always going to start at y equals 0. So as far as the transformations goes, it just doesn't matter what the base is. It'll change the graph slightly, but the kind of critical points of graphing these things isn't going to change. Okay. So transformations, we know that's our H value. We know H is negative. So it's actually negative 3. Remember, change the sign. So that means it's shifting left. And K is also negative 1, which means it's shifting down. Okay, the domain's not going to change. The only catch on the domain is like in a real life situation, whether it's financial or scientific or whatever, we may restrict the domain just because there's no such thing as negative time. But in general, the function itself, the domain is always going to be all real numbers. Okay, how about the range? Well, the one thing, and here is your general case here, the range, if it's not being reflected over the x-axis, then the range is just going to be the number k, that up and down shift, to infinity. Okay, so in this case, my k is negative 1, so my range is negative 1 to infinity. And then my horizontal asymptote, which I abbreviate HA, same thing, it's going to be y equals k all the time. There's no trick on that one. Whatever k is, that's going to be your HA. So it's going to be y equals, in this case, negative 1. So if you need to jot that down, I'm going to flip the page over and graph all of these things and kind of go from there. And remember, you don't need a piece of graph paper or a printer to print this out or whatever. You don't need that to graph these things. You can graph it by hand just on a blank piece of paper. So let's see here. So again, this is the same function we just had. So I'm going to put my asymptote at negative 1. That's the easiest thing to graph first. And then my critical point, remember, my critical point starts here at 0, 1. And then I'm going to shift. So left 3, down 1. So left 3, down 1. It's going to end up being right here. And I'm going to I'm not going to label it here, but I'm going to put right on top of the graph, critical point is now at negative 3, 0. We definitely want to label that. And then from there, it's just a general shape. Remember, there's no reflection, so it's doing the same thing as a parent function. So it's going to be asymptotic along here. It's going to go through here. And then once it goes through that critical point, it's going to go up pretty steeply. I'm not going to be super picky. Again, as long as it's kind of that general shape, I'm going to be happy. And that's it. Okay, so let's go back and look at the second example. Here we have a negative e to the x minus 2 plus 4. So again, now we're getting into some reflections, right? So we got a reflection across the x-axis. And then we're going right 2 and down 4. I'm sorry, up 4. Okay, again, domain always the same. Range, this is where you got to be a little bit tricky. So if you just kind of do just a rough sketch of an upside down exponential, it'll look like this, right? So that tells us our range also kind of is upside down, for lack of a better term. So my range, if it's going across the x-axis, is going to be from negative infinity to k, in this case 4. Okay, and I'll kind of write that in general here. So if it's a reflection across the x-axis, the range is going to be negative infinity to k. Okay, as I said a second ago, there's no trick on the HA. The HA is always going to be y equals k. So in this case, y equals 4. So let's go ahead and take that. If you need to pause the video and jot that down, you certainly can. But let's go ahead and take that information and put all that on a graph. So again, let's draw my asymptote. 1, 2, 3, 4. Now here is the warning, and I have it on top of the page right here. If there is a reflection, do that before you do any shifting. It's really important that you reflect before you shift. Okay? So again, we start here. That's my 0, 1 for my parent function. If I reflect that over the x-axis, it's going to flip over. So now it's here at negative 1. And then I'm going to go right 2 and then up 4. Okay, I'm going to do that one more time. So parent function, normal critical point 0, 1. Flip it, reflect it over. So it's 0, 1. So it's 0, negative 1. Right 2, up 4. And there is my critical point, which would be 2, 3. And then we're just going to sketch it in. And again, to keep in mind, it's upside down, right? So this is like the normal parent function. If I flip it over, it's just going to go, it's going to be asymptotic on the left. And then once it goes through here, pretty steep going down instead of going up. So it's going to go through here, kind of like that. And that is down. Okay, again, I'm looking for 3 things. Is the asymptote in the right place? Is the critical point in the right place? Is the general shape of the graph correct? Okay, last 2, if you want to pause the video and see if you can do these on your own, I'll tell you right now, D is as crazy as it's going to get. It's got all 4 of them going on. We'll go ahead and pause the video, and then we'll run through and finish this one up for today. Okay, so for part C, so again, negative up in the exponent, that's our B value, so that's a reflect across the y-axis. And then it's going right 1, down 3. Okay, domain always the same. Now notice my range here is like the parent function. It's not going over the x-axis, it's going over the y-axis, which doesn't change the range. So in this case, it's going to be from negative 3 to infinity. Remember, that's always the k value, k to infinity. And then the HA, y equals k. Okay, so again, my asymptote, my critical point. Notice, again, if I start at 0, 1, if I go across the y-axis, it ain't moving because it's on the y-axis, so we don't have to worry about that reflection across the y-axis, but I do need to go right 1 and down 3. So it's right here, which is the point 1, negative 2. Okay. Now, if you think of going backwards, and we kind of go up here, so this is kind of the normal shape, right? If I'm going backwards, now it's going to be asymptotic on the right, and then kind of going up to the left. This is the classic decay function. So it's going to be kind of like this, goes from our critical point, and then it goes up pretty steep from there. Okay. And then the last one, we got all four. Reflect across the x-axis, reflect across the y-axis. And then it's go on left 2 and up 3. Domain all the same. Remember, if it's going across the x-axis, the range is also reflected or flipped, however you want to think of that. So my range is going to be from negative infinity to 3. And my HA is going to be y equals 3. Okay, so asymptote first. Critical point. So again, we start here. Reflecting across the y-axis doesn't do anything. Reflect across the x-axis, flips it to -1, and then left 2, and then up 3. So the critical point's going to be right here at -2, 2. Reflect across the x-axis, left 2, up 3. Okay? And then think of it in terms of being upside down and backwards. So this was the backwards graph right here. So I can just make it upside down. So now it's going to be asymptotic here, but then going down. So asymptotic here, going through my critical point, and then pretty steep going down like that. And that is graphing exponential functions. Remember, asymptote, y equals k, always. The range, it's either k to infinity or negative infinity to k, depending on if it's being reflected over the x-axis. Graph your critical point with your shifting. Remember, when you're doing the critical point, make sure that you're doing the reflecting before you shift, and then just the general shape of the graph. If you have any questions, please let me know. Come in tutoring, ask a question during class. Until next time, stay safe.